Hello, my name is Luke Askew, and today I'll be presenting my international case study on the 2025 Darjeeling and Nepal floods and landslides. This disaster occurred in the eastern Himalayan region and was triggered by unusual intense rainfall that led to severe flooding and major slope failures, like the scene shown here. In the next few minutes, I'm going to walk through what happened during this event and then explain the scientific concepts behind it, focusing on the hydrologic cycle and erosion. These concepts from Modules 6 and 7 help us understand why this region is so vulnerable and how environmental and human factors combined create such a destructive outcome. Okay. So, what happened? To understand the science behind this event, it's important to first look at what actually happened on the ground. So, in early October, several days of intense rainfall hit the Darjeeling district in India in the Lam region of Nepal. This rainfall overwhelmed mountain towns, filled drainage systems, and caused severe flooding throughout the area. As the soils became saturated, the steep Himalayan slopes failed in multiple locations, triggering large and destructive landslides like the one shown here. Homes, roads, and key infrastructures were damaged or completely swept away. Dozens of people were killed and thousands were displaced across both countries. This sets the stage for understanding why this region is so vulnerable and how natural process contributed to the scale of the disaster. Now on slide 3, I want to explain why this rainfall was so extreme. And this ties directly into the hydrologic cycle. During early October, the region was still influenced by the end of the monsoon season. That means warm, moisture-filled air was being pushed into the Himalayas, and because warm air can hold more water vapor, when that air cools as it rises up the mountains, it releases a huge amount of rain in a short time. In this case, the rain was falling faster than the soil could absorb it. The ground hit its saturation point really quick, and once that happened, all extra rainfall just became surface runoff. On steep mountain slopes, that rapid runoff adds a lot of stress to the land. Eventually, the soil became completely waterlogged and unstable, which helped set the stage for the landslides that followed. Alright, so slide 4 explains the second major factor behind this disaster, which is erosion and slope failure. The Himalayan region is naturally very steep, and that already makes it prone to erosion. But in Darjeeling, human activities like deforestation, road cutting, and changes in land use weaken the soil even more. When you combine those weakened slopes with the extreme rainfall we just talked about, the soil starts to lose its strength. As the ground becomes saturated, the soil gets heavier and gravity basically starts pulling everything downward. That's when large sections of hillside begin to fail. What's interesting in that, scientific studies done before this event, like the one shown in this suspectability map, had already identified those exact zones as being a very high risk for landslides. And those high risk areas ended up being the same areas that collapsed during the October 2025 disaster. These are some of the major impacts from the event. Dozens of people were killed and thousands were displaced across both India and Nepal. Homes, roads, and bridges were destroyed, and a lot of communities were completely cut off because the main access routes were blocked or washed out. Essential services like power, clean water, and communication went down, and the landslides dumped tons of debris into nearby rivers, which made the flooding even worse. Relief Web also reported that military and local rescue teams had to step in and evacuate people and restore access to the isolated areas. This is what the response looked like after the landslides hit. According to the Telegraph India, the Geological Survey of India had actually issued an orange landslide warning before the event, but a lot of communities still weren't fully prepared. Once the damage occurred, road clearing and rescue operations started right away, as you can see below. So to wrap everything up, This event really shows why these environmental concepts matter. The extreme rainfall from the hydrologic cycle and the weakened slopes from erosion and land use changes created a perfect setup for landslides. Shows how important early warnings, good infrastructure, and community preparedness are, especially in places like the Himalayas. Overall, this case highlights how understanding hydrology and erosion isn't just academic. It directly affects people's safety. And events like this can help guide better planning and disaster responses in the future. Thank you.